So first is just defining a rational function. So a rational function can be written as the quotient of two polynomial functions. So the reason we had to do a unit review on polynomials is they're not going away. P of x and Q of x have to be a polynomial function. So you have to know what a polynomial is. You have to know its degree. You have to know how to factor it. All those things in order to be successful in rational functions. And it says Q of x is not 0, right? Because you can't divide by 0. But y equals 0, that horizontal line, is a polynomial function. We just can't use that one in this case because you can't have 0 in the denominator. And P of x and Q of x have no common factors. We alluded a little bit to what's going to happen when you have common factors and you cancel things, but we'll talk about that more on the notes 019 because that's when we have holes in our function. So in this whole set of notes, we're not going to see common factors, not till we get to 19, kind of the step up. Now there's going to be holes in our rational functions. And here are just 3 examples of rational functions. You've already seen them quite a bit just from that little introductory exploration, but you should already be able to identify what x's are not going to be allowed by looking at the denominator of your function. So in the first example, what could x not be allowed to be? -1. So x cannot equal -1 in this function. So that's going to get into our vertical asymptotes and our domain. In number 2, you might not be able to tell because this is in standard form. So hopefully now we could quickly put it into factored form without having to think too hard, right? X times x. I'm looking for the factors of -6 that add up to -1. So -3, +2. I have to be able to factor in order to get the undefined values to show up. +3 will be undefined, and -2 would be undefined. So you have to factor correctly to get your undefined values. And on the last one, what could x not be? 1. And so then this bottom part basically just talks about what we've already talked about a little bit. Graphing a rational function can be tricky, but we're going to follow the same procedure each time. First, we're going to find our x and y intercepts, and then we're going to find our asymptotes. Then put it all on the graph and graph it. And then if we want to find more points, all we have to do is plug in values for x. So if I want a couple additional points on my graph, I could plug in 5 and see what I get, and then plot that point, 5, 8 or whatever. And then the 2 things that we have to remember, these are called rational functions, so they'll always pass the vertical line test. So for example, when you're looking at your elbows of your graph, you're never going to have one elbow on top of the other elbow, right? Because that would fail the vertical line test, right? So fail the vertical line test. So these are always going to be functions. So putting your different parts of the graph in different regions, you want to keep that part in mind. And then graphs are always going to hug your asymptotes. So if you've got, an asymptote here, this is getting closer and closer to this asymptote, but it doesn't poke through the asymptote most of the time. There's going to be a couple exceptions, but we want to use our asymptotes kind of as our wall of the function. It kind of frames our function for us. So hopefully just from that introduction, you kind of already know a little bit about each of these pieces. So this first part is just having you practice 4 different times finding the x and y intercept, like the baby step. Find the intercepts first, practice finding the asymptotes, then we can put it all together on the graph when we're really good at those steps. So to find a y-intercept, you're just going to plug in 0. So let's do all the y-intercepts first on this page. So let's do the first one together. If I plug in 0, I get 2 plus 0 over 0 minus 9. So what is my y-intercept for the first example? What do I get? Just -2/9, the fraction. So 0, -2/9. Even though this is a positive divided by a negative, I just write it as a negative number. right? As long as you have one negative, it's going to be -2/9. If it was -2 over -9, it would be +2/9. So could you take a minute and just do the y-intercepts of those other three functions just to practice how to find the y-intercept? That should be like an old strategy that you're more used to, but just try these three for a minute, and then we'll move on to the x for a minute. So on g of x, I got 0 in the numerator divided by -9. So 0 divided by anything is 0. In h of x, I got -5/8. And in j of x, this time I had a problem because I got 0 in the denominator. So 1 divided by 0, I can't do that. It's undefined. So sometimes there might be no y-intercept, and that's okay. It probably deals with there being an asymptote along the y-axis. So it's okay to have no y-intercept. And for full credit on a test or a quiz, you don't want to leave this as 0 divided by -9. You want to write it as 0. You don't want to write this as 1 divided by 0. You want to write your conclusion no y-intercept. Any questions on that part? Pretty clear on y-intercept? That's always your first step. Tackle the y-intercept first. Plug in 0 and see what you get. Then your next step is go to the numerator. So the reason why we can use a shortcut for the numerator, I'm just going to show you why this is a shortcut. So on our first function, the real definition for finding an x-intercept is you plug in 0 for y, right? That's really what you're doing. So if this function said y equals 2 plus x, you don't have to write this part, but if this said y equals 2 plus x over x minus 9, if my first step is to plug in 0 for y, what is really happening when I solve this function? So I really have 0 equals 2 plus x over x minus 9. The first step when you solve a fraction involving x is to get the stuff out of the denominator. So my first step is actually to multiply both sides of the equation by x minus 9. Well, isn't 0 times x minus 9 still 0 on the left-hand side? So see how the shortcut really is just setting the numerator equal to 0 and solving for x? So I consider that a shortcut. I ignore this whole process and I just have memorized where is the numerator equal to 0, that's going to be my x-intercept. Because whatever I plug in, if the numerator is 0, 0 divided by anything is going to be 0. So x would have to be -2. So -2 comma 0 is my x-intercept. If I plug in -2 over here, I get 0 divided by -11, which is 0. Let's do these together. So on the next one, my numerator is x. Well, what's going to make x equal to 0? 0, right? So this one is going to have an x-intercept at 0. Hey, our x-intercept should match our y-intercept, right? Because they both are at 0, 0. So that should make sense. Everything should fit together like a puzzle. In h, you're going to have to factor before you solve this problem. So you have x squared plus 6x plus 5 equals 0. Use your factoring skills to solve for those zeros. So see how it's still practicing your factoring skills all throughout this unit. So take a minute and factor that one on your own to find your two x-intercepts. So you might have more than one x-intercept. All right, so x plus 5, x plus 1 equals 0. So my two x-intercepts would be at -5, 0, and -1, 0. So if you still need help with factoring, reach out to me. I can give you some more practice sheets like with answer keys. CUTA, K-U-T-A, CUTA Algebra is a really good free resource. You can print worksheets on whatever you want with answers. So if you need help with factoring, you still have a whole week before your test. You want to get good at factoring. And then what happens with j of x? My numerator is 1. So can 1 ever equal 0? No. So there's actually no x-intercept for this problem. Similarly, there was no y-intercept on that same problem, probably an asymptote issue. All right, so those are your first two steps for any rational function that you look at. y-intercepts and x-intercepts. So you plug in 0 first, set your numerator equal to 0. Step number 3 is finding your vertical and horizontal asymptotes. I do the vertical first because that's my denominator. So I just looked at the numerator for the x-intercepts. Now I'm going to look at the denominator for the vertical asymptotes. And I also talked about domain here because this is how we find the domain restrictions. I want to show you the difference in how you write your vertical asymptote and how you write your domain. Remember, we talked about domain on the front page. So we already know how to write domain restrictions. X cannot equal. Vertical asymptotes are written x equals because it's a vertical line. So look at our denominator. What is our bad value for x? -3. Because when I plug in -3, I get 0. So x equals -3 is how you write your vertical asymptote, but x cannot equal -3 is how you write your domain restriction. So this assumes all real numbers except x cannot equal -3. And sometimes you might have to factor first to make sure that you're finding all of your domain restrictions. This happens to factor into the same factor twice because it was a perfect square trinomial. So we only have the one restriction at 1, right? So x equals 1 is my vertical asymptote. X cannot equal 1 is how I'd write a domain restriction. I'm going to be picky about that because I want you to be communicating the right mathematical thing. Are you communicating a line or are you communicating a domain restriction? It looks like a subtle difference, but there's a big difference in those two things. All right, so vertical asymptotes. I want to skip to the next page. So I actually am gonna just do the vertical asymptotes first to try to keep that straight in your mind. You're gonna go through the denominator of each of these 8, so there's 8 of them. Go on to the next page. So there's 8 examples of finding vertical asymptotes. We're going to do that step just to keep it straight in our mind. So for example, the first vertical asymptote is at x equals 9. So I'd like you to take a couple minutes and do those other 7 problems. You might have to factor, like this next one, x squared minus 9 equals 0. You'd have to factor that first using difference of squares and then find the solutions, which you should be able to do from your polynomial test. So pause this. Did you get 3 or -3? So there's 2 vertical asymptotes. X equals 8. Some of you might have struggled on factoring J because it's a GCF, greatest common factor. I'm not sure why we're struggling with greatest common factor, but that's how you would factor it. When it's x squared, 0 is one of your undefined values, your vertical asymptote, or 2. We okay on that page? And then I went through and did this page. If you said 2 or -2, I know what you were doing. You were thinking about difference of squares. But if you have x squared plus 4 equals 0, this is always going to be a positive number. When you subtract 4 to the other side, you can't take the square root of -4. So this is considered prime. So there's no vertical asymptotes. Your denominator will never be 0. Because if you plug in -2, you're going to get 8 down there. 4 plus 4 is 8. So don't be tricked and think there has to be a vertical asymptote because there might not be. And then n was 0, q was at -1, and then t was also at 0. So hopefully your brain is starting to be like, okay, I just see it. I know where it's undefined in the denominator. So then the last rule I wanted to go over, maybe I haven't done this enough to have you practice it tonight, so maybe I won't give you homework, I don't know. All right, let's see. Horizontal or slant asymptote. It's a 3-part rule. Here it is. It's up here for you. You're going to compare your numerator versus your denominator. So part 1, if the numerator wins and is exactly 1 higher, like x squared over x or x cubed over x squared, you're going to find the slant asymptote using division. So we already have seen that a little bit. If the denominator wins, so the denominator is higher, then the horizontal asymptote will just be at y equals 0 because basically the denominator is blowing up and a number divided by a really big number is 0. 1 divided by a million is 0.0000001. And then if the powers are equal, so if the numerator and denominator are equal in degree, you're going to strip the coefficients. The powers are equal. The horizontal asymptote is the ratio of the coefficients. So let's go through the first 4 together, and then maybe you can try the next 4 on your own. So we're going to scan for the degree of the numerator and the degree of the denominator. What would you say? Does the numerator or denominator win, or are they equal in degree? Equal. They're both linear functions, right? First degree functions. All right, so we're going to go to this rule. Numerator is equal to denominator in power. It's the ratio of the coefficients of the leading terms. So by leading terms, they made leading coefficients. So this is 1x divided by 1x. So my horizontal asymptote is at 1 over 1, or just y equals 1. So you strip the coefficients of those leading terms. All right, who wins the battle in g of x? Who is the bigger power? Denominator, it's quadratic, right? So if the denominator is a bigger power, it's going to blow up, like 1 divided by a really big number. So it's y equals 0. So as x gets really, really big, a quadratic function grows faster than a linear function. So you're going to have a small number divided by a really big number. So y equals 0. What's going to happen in h of x? Who's going to win the battle? The numerator, right? X squared. So if the numerator wins, you double check. Is the numerator exactly 1 degree higher? It is, right? X squared divided by x. So you are going to do either division, box method, whatever. I put synthetic. I didn't show you that this year. So we're going to do division. We're going to take x minus 8 and divide it into this dividend, x squared plus 6x plus 5. So I'll get you started. Put your x squared there. See if you can do division to find your slant asymptote. I'll put it up in a minute anyway to help you. All right, so I'm going to finish it. I get negative 8x in the bottom. I'm trying to get to positive 6x for my dividend. So if I'm at negative 8 in the whole, I would have to come up positive 14, right? Because negative 8 plus 14 would get me to 6x. So the last part of my answer is plus 14 up here. I really don't care about the rest of it. I don't even know what 14 times 8 is. Is that 112? All right. Good mental math. Negative 112. I'm trying to get to 5 as my dividend. So 117 is my remainder if I care. But y equals x plus 14 is the slant asymptote. The remainder is just preventing you from getting there. I'm not quite at x plus 14. I'm off by a little bit. So that's why your graph is going to hug this asymptote, but it can't quite get to that asymptote because of the remainder. And the last one, where's the bigger power? Denominator. So if the denominator is bigger, my asymptote is at y equals 0, right? All right, so you are going to try the horizontal or slant asymptote on this page. And then we haven't done the graphs of putting it all together. So I'm not going to do the graphs as your homework. I'm going to do page 21. So first, finish these 4, and then I'm going to explain to you what your homework is. My 4 answers up here. So let's see, this one, they were equal degrees. So you strip the coefficient, so it would be y equals 2 over 1. So y equals 2 is your horizontal asymptote line. Let's see, n of x, the denominator's bigger, so y equals 0. Q of x is when you've got to do your division, right? So you put x plus 1, and then you've got 3x squared here, because that's your dividend. So you need 3x up top. This would be positive 3x. I'm trying to get to negative 2x in my dividend, so I need to subtract 5x to get to negative 2x. So it looks like my asymptote is 3x minus 5. I could finish this. Negative 5. I'm trying to get to 5, so remainder of 10, right? It's just nice that there is a remainder. If not, there's a problem, there's a hole, and they were factors of each other. So it's nice that, yeah, there is a remainder. And then this last one, the denominator's bigger, so y equals 0. So if those skills seem really slow and challenging for you, I'm hoping that by doing kind of 12 questions between today and tomorrow, whether it's during flex or at home or in 10 minutes before class tomorrow, maybe you'll need more than 10, I don't know. You're only doing the first page, number 1 through 12, on 21 in your notebook. So maybe pull out 21 and put it at the front of your notebook so you remember to do it for tomorrow. I'm going to check it off. No, we're not doing the graphs at all. Page, it says 021 at the top. You've got it, Shane. So you got to keep flipping, Jack, ahead. That's all 18. So it's a different page. It looks like this. So it gives you what here. So you've got it. You saw her one, right? It's not in the book. It's just this page. Number 21. Front page will be 1 through 12. Like, just pull it out, put it in the front of your notebook so you know which one it is. And I'm talking about the one you can right? I'm sorry. All right, you got it? 21, 21? All right. So you've got a couple minutes left. I mean, you could just look at it for a minute, or you could pack up. So you were doing 21, 1 through 12 as homework.